All right. So the plan is that we have prepared nothing, and you do all the work. So you're the one asking the questions, and we are going to try to answer, which is a different story. So before we start, we may maybe introduce ourselves so that you know what questions you can ask. So I'll start. So my name is Stéphane Nicoll. I'm working on the Spring Boot and Spring Framework team. I'm also the lead of Spring.io, a service that allows you to get started easily with Spring. So I can try to answer questions in that area.
Hi, my name is Orhan. Most of you maybe know me with talks about Spring Cloud in the past years, and also I'm basically talking most of them about the architecture. So from Java and Spring point of view, my best interest is about how things are going to evolve to future, so that will Spring cover everything, or what's not covering, and what is the alternatives there? Do we have them, or Spring does everything? So I think that could be an interesting topic for today. So I have a few also, I would say, questions that I would like to throw in to discuss with everybody. I'll keep it surprise for now, but let's see.
Hello, my name is Oleh. Most of the time I work on Reactive, so this is a pretty hot topic. And most probably, or perhaps, I will be able to answer question on Project Reactor because I'm contributor of this project. RSocket, this is a project on which I'm working, and this is a pretty hot topic for Spring right now and nowadays. And also, I know how R2DBC and everything with the word reactive works. So I will try to answer something, but yeah, this is my area and sphere of knowledge.
Okay, my name is Nicoll. I'm not a contributor, but I'm active user of Spring ecosystem. It seems that I have been used Spring framework since first release candidates. It's more than 50 years right now, 15 years. And I'm, again, active user of Spring Boot ecosystem and performed many talks on this topic, so I could be helpful in this.
All right, question.
This is non-official or kind of pushed by us conversation or talk. So everyone from the audience are able to answer, to ask any question, to run any discussion, to perform anything in order to do this not a like normal session or presentation, but as a conversation between you and I, and like us and you.
I will give you some examples. So, for example, you come here with a particular question. So, when will be released something in Spring Boot or Spring ecosystem or something else? You could start this conversation asking this question, and we will continue it. So, it's very informal session. Without you, without your participation, it will be nothing. So, we will just share some of our opinions, and that's it.
Okay, let me start then. I just wonder, why did you write web flux and just didn't use Alex Java? I mean, the whole interface, everything looks the same stuff, but different. You are using flux and they are using observables. What's the idea or the intent behind this?
I can try. Yeah, you can start. All right. So basically, this is the question, not like why WebFlux, but maybe why Project Reactor, because RX Java is less comparable to WebFlux, because WebFlux is just like replacement for WebMVC at some way. So maybe I have to correct and say what is the difference and why Project Reactor. So basically Project Reactor because it's based on Java 8. So all of the future of Java 8 are available in Project Reactor ecosystem, like ability to create stream from Java Stream, for example, or create stream from completable future, which is not available in Java 6 and 7. So this is one of the reasons. On the other hand, Project Reactor implements reactive streams. So this is the main idea of Project Reactor. Of course, RxJava 2nd also provides some implementation of Reactive Streams API, which is... Yeah.
Let me interrupt. I thought that I wonder and checked how Spring make things reactive, and it's rely on the servlet specification 3.1. So actually reactive thing is servlet 3.1, right? I mean, WebFlux, I mean, the reactor thing is it's a library or something. Or I'm misunderstood, correct me if I am wrong.
So, I got a little bit of confusion here. You say it's servlet 3, right?
Servlet specification 3.1.
Right.
Right? This is how Spring make things reactive.
No, it's not how it works. Under the hood there is Netty. So this is the main guy in Spring WebFlux. But you are able to connect along with, for example, Netty, you're able to connect Tomcat based on servlet 3.1, which supports asynchronous data sending. But maybe, Stéphane, you can add more on that.
So yeah, so the WebFlux basically gives you an abstraction, and if you use Netty, then you're using the Reactive Streams implementation directly, so you reuse the Netty thread pool, so you have a direct integration with it. But we wanted to give you as much choices as you can, so the integration we have with Servlet 3.1 async is just a way for you to be able to deploy your WebFlux application in other environments, additional environments like. And there is also like dedicated API integration with Tomcat and Undertow. So there is a dedicated API outside of the servlet space for which WebFlux has a direct integration. So typically you would use a WebFlux application on Netty, right? This is where you'll get the full power, you'll get the full reactive experience. But if you have to deploy that application on Tomcat, then we will provide you an integration using, as you've said, Servlet 3.1 async. But that's not really the main integration, right? The main integration is with Netty.
Just making story short, WebFlux is more like an abstraction around it, and it could be implemented with different backend technologies, like for example Netty, like Tomcat specifics, like other things. So, and the WebFlux will work the same for you, independently what particular web server you will use for this purpose. And the Spring Reactor, I think one of the reasons Spring Reactor is going on and used so much is a historical reason, because RxJava 1 and Java 8 that was delivered a little bit after it, and new reactive, I think, movement was started in the middle of these events. And that's why many different libraries and many different frameworks started almost at the same time. And they tried to bring some specification, and usually specification is built like, remember Hibernate and other frameworks that affected JPA born. So initially we had different implementations, and only then we decided to make an abstraction, and this abstraction became true for us, and we started using it. The same situation was here, so it was RxJava with some abstraction, then Project Reactor with another abstraction, and then we have in Java 9 this flow thing and so on. So we try to build abstraction on basis of working things. And if things works, we choose the best parts and then bring new abstractions.
And one more to conclude. So there is really two things that's really important in Project Reactor from my perspective. One is that it implements Reactive Streams natively, so it's a direct implementation of the publisher type, whereas in RxJava 2 you have to use an adapter, as far as I know, right? You have to use an adapter for RxJava 2. And so that's one thing. So you have like native compatibility with Reactive Streams. And the other part is you mentioned, okay, it has map, it has flat map and everything. So these are the operators you can apply on a publisher. But the level of those operators, the quality of those operators, that's what really matters. And there is really a lot of things you can do. I'm not saying you can't you can't do anything with RxJava 2, but also the richness of operators is quite important from my perspective.
So, I just wanted a question.
I have another question, not related to.
Yeah, let's go.
So, did you have some real project example that you have some synchronous API, you refactored your service to Reactive API, and you get the performance boost? And if so, which the percentage, 5, 10, 30?
So basically, I don't have like real projects, like big enterprise, but the simplest you can do, you can go for like Tech Empower. I'm not saying that this is super like kind of correct or let's say appropriate benchmarks, but there is Tech Empower, and they're running different frameworks and comparison between them. So the main what you can do is go to Tech Empower and take a look, for example, Spring and Spring Web Flux, and what you're going to see is like 60 or 70% win in performance just by switching from Spring Web MVC to Spring Web Flux. That's what the baseline which you can get. And of course, the test that they ran was like 20 queries, which is lots of I/O. So you will get really good performance benefit once you have like the use case of lots of calls to different microservices, and in that case you will most probably get like performance burst by using non-blocking in Reactive API.
I think usually performance is not the main driver to switch into reactive. There are some different kinds of load. There is regular load, like you blocked by a client application, and client application could not work without the answer, so could not go to the next step. In this case, it's very strange to build something on the back end in reactive style because it's not natural. Even if you will get some benefits in terms of performance, I think it will be additional complexity in developers in terms of development. Usually, reactive is used when you have completely dedicated type of load. For example, event loading, or you have something like event generation on the backend side and you want to propagate them somewhere between microservices or somewhere else. In this case, regular stuff like Spring Web MVC traditional approach will work sometimes not so natural. And in this case, bringing reactive, you don't think about performance, you think about natural development models. And then naturally you will get better performance, because when you use unnatural models, you will get worse performance. And now I think one of the blockers we have globally in terms of reactivity is relational databases. And most of traditional applications use relational database as a back office, so where all data is stored. And without reactivity at that level, we will have some input-output in non-reactive style. And all other things like data transformation, some pipelining and so on, is not so much performance in enterprise applications because data processing takes so much. And you could use, for example, in very simple applications when you say my data processing, I mean data storage will take 0, and then you build some benchmark, you could gain good results. If you introduce this database at the end and it's blocking database, you will have like 5%, 10%, but you have completely different model, development model, and complication will pay you bad.
So concerning the real projects, in my company we have several projects where we use reactive approach in production, and I totally agree this is not about performance, because if you do everything reactive, you may get performance boost or not. That really depends to dependencies. Each service, each code you write depends to other some factors, other artifacts. In our case, specifically in one of the projects that I have worked with, reactive was totally slower than non-reactive. It was worse. But the win point was not to use reactive for performance. We didn't want to get performance boost. We were okay with all the latency budgets, all the resource consumption budgets. The reason was, as Nikolai said, the data flow, or not even the data, the flow of development, how you do development. So from reactive point of view, the reactive flow of data through your processes, how you are doing the processing of the information that goes to input and output of your services, how you build the structure of your services, delivering the final solution. So it's more kind of an approach to your design of the system more than get a performance boost. You can get a performance boost by simply tuning what you have.
So yeah, I'm gonna a little bit disagree with both of the points because yeah, we have like two options. We have latency. Something went, all right, it works. So basically, if we are talking about latency, no, latency won't be improved. Most probably, yeah, it will be a little bit worse. But with reactive, especially with non-blocking approach, the main win is how your hardware is utilized. And another performance characteristic in which you can win is throughput. So basically with reactive and non-blocking, you will definitely get higher throughput. Because even though your database is processing query and there is no other case to get this query running faster, using the same hardware, instead of handling, for example, a K of simultaneous user requests, you will be able to handle 10K of simultaneous user requests without scaling your system. So this is, from my point, the main win. So you can decrease the spends on your cloud. For example, if it's just a single server, definitely use WebMVC and like care less about all this and use just imperative programming because it's simple and straightforward. But once it comes to handling like 100 of K or like 1,000 of K of simultaneous users, and you for that purpose you have to run like 1,000 of, I don't know, horizontal scaled machines, then most probably just switching your model from imperative blocking to non-blocking, you will win like pretty, you will get pretty huge improvement in terms of throughput on a single machine. But yeah, the problem with non-blocking is that non-blocking is pretty complex and hard. So if you're going to use netty, you will have to learn netty, you will have to learn how to work with netty, and this is really high challenge. So by using Spring Web Flux, you can abstract all these low-level things and get the benefits of writing like straightforward code, using Project Reactor, and using this like annotation-based style. Yeah, this is my point of view.
To make the long story short, it depends.
Yeah. So maybe then you could provide some suggestions in which cases it would be great to use React.
So if you have an MVC app and you're happy with the performance, given the current load that you have on your system, don't do anything. That's very easy. If you see that you need to scale more and more machines because the number of concurrent requests due to the latency or whatever backend service you're using, you see that you have to add more and more machine as your service becomes successful, then it's definitely the sweet spot to try to use Reactor, because as we've already discussed, the utilization of the server will be optimized if you switch to that mechanism. But don't go reactive to get like performance gain per request. That's not what you're going to get.
Okay, thank you.
Yes, thank you. The first question, could someone change background color, please, because it's very contrast. Thank you so much. So, yeah, thank you. Oh. Last time I saw you, all of you, I think, on Java EAConf, and here was selection. I'm sorry, I can ask everything about Spring, yeah? Yeah,
you can try.
Yeah, so, and here was selection from Evgen Borisov, you know him, and he talking about last version Spring when default proxy that was changed from Java dynamic proxy on CGI dynamic proxy, CGI proxy, sorry, CGI lib. And he promised that he goes here and first of all he goes in St. Petersburg and ask guys who developed this why he do this, and then go here in Devoxx and ask why. But he not go, and I want to ask you. Thank you.
You mean in Spring Boot why we've changed the default proxy from JDK proxy to CGI proxy? Is that your question?
Yeah.
So there were a few examples, but the one I do remember is an inconsistency behavior with regard to annotation retrieval. So if you use JDK proxy, you have like a strong requirements that the service that you expose needs to have an interface that represent the contract, and that's where the JDK proxy will be built on. So it forces you in a way to create that contract, even though it's not strictly necessary for the wrapping of whatever aspects you've added to your code. So let me take an example. You have a service and you would like to make it transactional. So you've annotated some of those methods as transactional so that the transaction manager will create a transaction if it needs to, roll back if there is an exception, commit if there is no exception, etc., etc. If you use JDK proxy, the only way this would work is if you had an interface where this contract is exposed, and then of course you need an implementation with your code in there. And well, why? So we didn't want you to, I guess the main theme is that we didn't want you to have to create that interface just for that reason.
No, I think, I'm sorry for misunderstanding. I know that in the last version of Spring, default bin creation is with CGI lib. Previously, we use Java dynamic proxy, yeah? And main reason for this, I don't...
That's what I just told you,
yeah,
is JDK proxy as forces you to create an interface, and we felt it wasn't the right move. But by the way, this is in a change in Spring Framework, and you can go back to JDK proxy if you prefer that. It's the default, right? It's the auto configuration. The auto configuration in Spring Boot will enable CGI proxy by default, whereas previously it was JDK proxy. So we've changed the default value of the proxy target class. But it's an opinion, right? So if you disagree with that opinion, like as always in Spring Boot, if you disagree with it, you can add enable aspect auto proxy with proxy target class equals false, and you'll be back to JDK proxy.
I'm not a Spring developer, and I have just an opinion. In the past, it was very unclear what kind of proxy will be built, because if you have an interface, you will have default to JDK-based proxy. If you don't have, you will have CGI proxy. And in this case, this mechanics is very fragile. So imagine that you initially had an interface, and then you just removed an interface. Nothing else was changed. And your mechanics, internals, could completely change. To avoid this, it was made a decision to make different defaults. But again, you could remove back and say, okay, I know that from performance perspectives, it's better to use JDK native proxying because of interfacing and more natural stuff. But if I want this particular mechanism to work here, I would mark it here, and in my particular application, it will work, and I will control this. This was the main reason, nothing else. Just to make it consistent. To avoid these tricky questions, what if we mark this annotation? And then you have, but we don't have this flag included and so on. And that's why this is working like this. So to avoid these tricky things, because tricky things are funny when you have puzzlers on the conference or in the pub or somewhere else, but this is like hours of spent time when you try to understand why your application doesn't work. That's why less consistency means more time spent on understanding what is going on.
I want to back to reactive, modern and buzzwords. Yeah. What is the state of front-end adoption for reactive stack, like socket and something like that? Because when I talk to front-end engineer, they always, what did you say? What is real socket? I don't know. I have never heard about it. And do you, I don't know, speak on conference, JavaScript conference or something like that, and share these technologies? It's the question for Oleh, and maybe other know something about this.
So, yeah, we are working on that, at least me doing that, talking. But in general, yeah, the first thing is like there was RxJava or RxJS for some period of time, and it is still there. Then I'm working on reactive streams for JavaScript, and I've been talking with the guy who stands behind RxJS, and most probably once it's done on the specification level, it's gonna come into RxJS as a standardized library, because from my point of view, yeah, there is Project Reactor for JavaScript. This is cool. However, there is not that many developers who are ready to support it and continuously do that. I've been trying to for example, support Project Reactor for Kafka, and like I've done some stuff, but then it turns that I don't have enough time to spend it continuously on the daily basis. So most probably one specification going to be implemented for JavaScript and tested finally. Then it's going to be ported to RxJS, and then it would be just a question of like talking and evangelizing all this stuff. But yeah, the process is going on. I'm trying to talk at JavaScript conferences as well and talk about our socket, especially as a technology for doing like reactive streaming over the wire. And yeah, let's hope for the best. Yeah, that's the answer they can provide.
And again, it seems that on the client side, most of our applications are still blocking. So we have user interactions, user do something and get some information and so on. All other stuff, like for example, getting events from the server, it's already implemented just with WebSocket. So you don't need some kind of additional specification. You just need additional adapter on the backend side, and you will send events using current technologies. That's why it's moving so slowly. So there is no good motivation to invent new things to work on. And everything is almost fine in most cases. There are cases, particular cases, when you like and want to have some specific library to work with Reactive on the backend side and continue working with it on the front-end side. But it's percent of products of applications with these needs is so small that people are just going in with current tools.
The easiest way is to put everything to socket and everything is okay.
I mean, like, if that question was about like libraries, then yeah, most probably for doing the request response, you don't have to use like observable. You don't need that, or Flux, or I don't know. But yeah, the reason to create our socket was to utilize performance to avoid all the pitfalls of HTTP2 to make your communication better everywhere and standardized, like using, for example, our socket spec.
But needs for that is very, very small percent.
I disagree. I disagree. Because like we are pushing our socket as a main replacement for HTTP2, and we are pushing it to W3C at some point in time. So we are hoping that it's going to be like a part of daily communication between client and server.
Knowing how V3C works, it will be like in 5 years.
Yeah, let's see.
At least.
Yeah, but we are pushing.
I have a point here. I'm not going to summarize and not going into too technical details, but the point is that really depends who is speaking about it and who is doing the thing. Because when we speak about technology, Who is this interested in technology? From business point of view, nobody. Business don't care about technology. Technology is just a key for getting the result. Any technology is good if I have money for it and people who can do it. Who cares about reactive technology, reactive front-end? Developers. If we have enough developers, as Oleg said, to support the thing, it's just interesting for us. If you want to get projects that will require it, any businessman, any man with power and money, they don't care about it. So it's up to you guys. You are developers, we are developers. You decide. If you are interested in it, go into community and let's do it together. So that's kind of this thing.
Hey, I have a question about Spring Cloud config. So we are not in the cloud, so we are living on premises. So we don't have the infrastructure that scales out and scales back. And currently we are configuring all the services using just Puppet. So we using infrastructure as a code to deploy the new configuration files. Is there any benefits for us if we're not in the cloud to use Spring Cloud config?
At the moment, initially Spring Cloud config was introduced like a component that is responsible for any kind of configuration for your microservices or other application parts. And it's covering both infrastructure settings and runtime settings. It means that infrastructure settings are settings that are passed to your application or microservice at the moment that application is starting. And then they don't change. This is what I mean by infrastructure settings. And another one, another part of this configuration is runtime configuration. So just an example, you have a token to Facebook and you just rotate this token and you want to pass this token to all microservices without restart and they will continue working. This is the second option that was covered by Spring Cloud config. At the moment, most of these things was implemented by other mechanics in particular orchestration platforms. Like an example, if you have Kubernetes, all infrastructure settings you pass through config maps or secrets. This is one part. Another part is Spring Cloud Kubernetes that implements the same thing for listening to config maps. And when config map or secret is changed inside Kubernetes, the same mechanics is working in your microservice, refresh context and so on, but without dedication to additional component. Because any additional component that is responsible for any part of your configuration must be highly available. It means that you need to run it in several exemplars and you need to somehow sync between them, split brain and so on. So it's good when your orchestration platform to take the most part of this complexity on itself. And Kubernetes is doing so, other platforms are also doing so, and probably there is no reason to use Spring Cloud config when you use some of these orchestration platforms. If no, you could cover almost everything with Puppet or some other technology, I mean at infrastructure level, but if you still have runtime configuration and you don't use orchestration platform to implement it instead of you, then Spring Cloud config is still needed.
Just to add a little bit more power to what just was said, so there are several moving parts here. At least the roles we are speaking about are your service, configuration it should receive, now Spring Cloud config client, and Spring Cloud config server. So your services should get configuration. This configuration is stored somewhere. Spring Cloud config client is the library, the abstraction that helps you to get this, load this configuration into your Spring application. Now, you can get it from any source. You can get it from Spring Cloud config server, which also has another source behind it. That depends to infrastructure. Your infrastructure may be in cloud, AWS, GCP, Azure, anything else, Heroku, anything else. They have their own components. Or it's an on-prem with Kubernetes or some other orchestrator. So where does these configs are stored? Where are they stored? And what is the format? What is the component that giving you these configs? Does Spring Cloud config client work with these component? Yes, directly integrate. No, you can use Spring Cloud Config Server or anything else in between to help to integrate. So basically, your service should get the configuration. Now you should integrate with it. Spring Cloud Config is the abstraction layer, and it has two parts, client and server. Pick the one you like, pick the one you need.
Thank you. May I ask one more question? Okay.
Sure.
So you see that the last version of Spring Boot for just today is 2.2.0. But how do you see the Spring Boot 3? So
nice one. I will add a little bit more into this question. But
would it be like something significantly different?
The honest answer is that we don't know. We don't know because if you look at the past of Spring, and if you look at what we've done, we've always reacted to the community and what other projects were doing, like something new coming up, like our socket. Oh, that stuff is cool. Let's try. Should we integrate with it? Oh yeah, it's actually very interesting. So let's do that. You've seen trends about Java, so there is one thing that you can probably expect, even though it's not firmly defined. But Spring Boot 3 is probably going to require Java 11, and it will go along with Spring Framework 6. So that's probably most probably what's going to happen. So the moving the system requirements is the most obvious one. Now for the content itself, why would we require to switch to a new major release? We just don't know yet.
I have an opinion on this point, on this question. We have now very strong and modern trends. And one of them is container native Java applications. It means that our Java applications must eat less memory in terms of class loading, in terms of runtime, in terms of everything. And our Java applications should be packaged as small as possible. Because many people trying to scale microservices and trying to roll out very quickly, and this startup time and time to download on each instance image with your new system is very important factors. And memory utilization is also important aspect because you want to run more services on the same instance, on the same machine. That's why we have Quarkus right now. We have other frameworks that try to minimize footprint of your microservice. And we used to have very simple model when you have Maven or Gradle, you add all dependencies you want to put inside, and starters bring more dependencies, and you build some artifact with 100 megabytes, then you load it, it's by default with hello world like 256 megabyte of RAM minimum. Ideally, you say half a gigabyte will be enough to say hello world. And this is not what should going on in modern Java. And this is a very strong trend. I believe that the next version of Spring Boot could do something with this, because Spring Boot is very popular development platform. I mean platform in all terms. So people use it not like a library or framework. It's really platform because it integrates with everything possible. You have starters for every technology. That's why I believe that this trend will affect future versions. Which one, 3.0, 4.0, I don't know, but it's very important trends, and we could not ignore it.
So quickly on that, very good point, I agree, but that will not require a new major release, and that's already in the works, so there is something we are working on.
So just a little bit adding another point of view here. So it's been 5 years from the moment since we got Spring Boot on the stage, 2014. I mean the general release, where everybody knew about it and started using, and 4 years from 2015 when we got Spring Cloud. So at that years, we used Java Enterprise, then we started using Spring Boot because it's more lightweight, it's open for microservices, it's not another way of doing monolith, and so on. Then during all of these years, what happened, just think about it. So if you're asking what could be next, so I think that Spring community should think about, just answer for the question, guys, what do you think? How different modern Spring is from old Java Enterprise? Isn't it another huge framework with all components? Yes, they are small components, but Java Enterprise had the same thing. We also have micro frameworks, even a micro profile. So I think there is a room, definitely a room, for another micro framework just appear from somewhere and get the market. So it can be Spring 3.0 or it can be something else. Just an opinion, think about it.
Quarkus from Red Hat is trying to do this, and to bring something new, it's not only like, okay, we are small. We are small in terms of how simple is our components, how simply we could configure our microservices, but you need to bring some benefits to end business. Talking about the size of your footprint, the size of your artifacts, it's very easy to explain business why we should use something instead of Spring Boot, for example. Because you could really save much RAM, you could really save much network traffic, you could start quicker, and so on. And business understands this. Business don't care about, here I have fancy annotations, or here I need 2 starters instead of 5 libraries. Nobody cares. But in this thing, if I could utilize and run 10 times more microservices on the same node, or if each of my microservices with GraalVM could start, and other technologies could start in 100 milliseconds instead of 20 seconds, for business it matters. Nothing else matters.
Hey guys, thank you. My name is Nicoll, so I'd like to touch maybe a little bit different, but maybe related topics. So there's an ongoing trend of moving more processing to compile time in Java world, and there are frameworks for that. So I know that Spring does some minimal stuff for that, like indexing components in compile time, but some researches of moving more of Spring logic to compile time optionally.
So yeah, I agree. It's been a trend. It's still a trend. So there are a few projects using that approach. What we are trying to do, and we've already worked quite a lot in Spring Framework 5.2 and Spring Boot 2.2, so it's GA now. You can use the improvements in those releases. What we are trying to do is to revisit the performance of doing the lookup at runtime, so that you can still benefit from all the features that you enjoy, without the drawback of ahead of time compilation. One example of that is we want to make sure you don't have like a complex ID setup. Usually if you do ahead of time, it's either related to annotation processing on something that's integrated in your build, so sometimes it's not very easy to integrate depending on the ID you're using and other glitches. So it's one point where we try to get away with it. Something else we've been working on is in 5.2 is we have now a new annotation retrieval API, and one plan is to be able to back that annotation retrieval with a cache. So you mentioned Spring Components, spot on, so that's really one of the things we've done. What we will try to do is to also compute that information at build time, so that optionally you could use it to improve startup time. So really what we want to do is not go with an approach where we go from one to the other, and if you don't have your indexes up to date, the application will just crash. We just want to make sure that if the information is available, we can use it and optimize startup time. But if it's not there, your application will work just fine. It may take a few milliseconds more to start up. but it will not crash. So that's really our initiative right now. There's also another initiative to allow you to configure your application explicitly without the use of annotations. So basically configure your application programmatically. There's been a bunch of initiatives in the recent past. So there is a WebMVC FN, and WebFlux FN, which are two alternatives to the request mapping annotations. So something where you can define your web router programmatically without annotations. So it's much more explicit. There's also an incubating project called SpringFoo, which goes to that direction, but on the configuration front. And this is something that's really very tailored to the Kotlin support that we have, because there we can provide a dedicated DSL, which is really easy to use and easy to read. And so there's a bunch of initiatives in this area. So yeah, we are working on this. More questions?
Yeah, I want to ask, what is the insights about running and monitoring startup Spring.io? What's actually people trying to generate there? Stéphane, it's for you, probably. Startup Spring.io. What's actually users trying to do there? Funny things or some insights, or how often it's actually used?
So if you understood the question correctly, you're asking if there are any specific trends on Spring.io, what kind of things? Okay, so every time you create a project on Spring.io, we take a snapshot of your decisions. So if you decided to go with Gradle, we will snapshot that. If you've selected dependencies, we snapshot that. If you change the Spring Boot version, we snapshot that. And we record that anonymously. So the plan is for us to understand how the community is using the service. And it also drives some decision about investment, right? So if we look at a starter and basically nobody using that stuff, then, well, we know that maybe there's something wrong. Either the usage is wrong, or the documentation is wrong, or we need to talk about it more. So this is really an indicator for us. So for the most part, you generate web applications. So for the very, very big part, you always include web starter for some reason. So everybody's writing web applications. What a surprise, right? The second thing obvious is like massive usage of JPA. There's really a bunch of people using JPA. It's really super high. If you look at the split of data stores, for instance, so if you look at every data store options we have on the site, be it SQL, NoSQL, whatever, you have like JPA like 80% or something like that. So if you want to reach a data store, 80% of the time you're using JPA. Of course, that doesn't mean that 80% of applications using a data store use JPA, because it's just a statistics about getting started, or you can maybe work on a prototype, whatever. If you look at template engines, like Timeleaf is skyrocketing. It's like the #1 by far. And you are lazy, so you keep the default options, right? So if we say Maven Java 8, you go Maven Java 8. You don't change it. No surprise there. What else can I say about Spring.io? How much projects? How much projects do you think we generate per year? So last year, last 12 months, how much projects? Who goes with 100,000? Nobody. 1 million? I have a few, okay. 5 millions? 2? 10 millions? No one. So the answer is 15 millions. 15 millions. 15 millions, yeah. So again, we know what we know because we had a survey about it. We know that there are use cases where you go to Spring.io, you just want to look at something. So you just create quickly a project, you open it, and okay, and you trash it right away. So that's why we've implemented the explore feature on the site. So you can actually see the content of the project without downloading it. That's the #1 reason we've done that, because we had like a bunch of users coming back to us saying, oh, I have to download the zip and then look at it. It's really annoying. Can you please do something so that I can see the information right away? So we know, one, that there is project generation just for that. Two, we know that there is no 15 million project going to production. There is a lot of prototyping and sampling and back reporting and whatever. But still, it's very highly used. So let's go with more quiz. About countries. Any idea who the third top country would be? So the third. Who's the third? The second, sorry. I already said third. That's the USA, and the first is China. And China is close, or even, I think it's more than 50% now of traffic. So if you look at China, one project on 2 is from China. It's really completely insane. Okay, one more. Then I shut up.
Do you have information about IntelliJ IDEA generate project statistical?
I was about to say that, actually. I was about to ask a question about that. So if we split the usage of the service into the web browser, so that's start.spring.io, command line clients, so that's HTTP PI, curl. You know that you can also use the Spring CLI to create a project if you don't know, right? Spring CLI, Spring Init, you can get started on the command line. So the second topic, so browser, command line, and the IDEs is the third, so that's NetBeans, STS, IntelliJ IDE, VS Code. Who thinks that the web use case is the first? So the top usage is the web browser. Who thinks that? A few. Okay. Command line. Command line is not the first. Definitely not. IDE. So IDE is 75% of usage. And if you remove China, that goes down significantly. It's like, if you remove China from the equation, it's more like 49 maybe %. And the browser is just 1% above. So if you remove China, it's 50-50, like browser IDE, pretty much the same. If you put China, it's 75% from the IDE. I don't know why. Less than 1%, I think. No. Any more questions?
Kotlin usages. I mean, do you have statistics for Kotlin and Java?
Well, Java is the default, so it's like 98% or something like that. I think it's not fair because when you go on the site, sometimes you forgot you had to change the language. So it's the default option, so you can't really compare. You can't really extract something based on that, I think.
Okay, one more question. As far as I know, Pivotal is committing to the Jakarta AI, right? So how is the things are going between Spring and Jakarta AI? Is it a competitor to you, or you are doing things together, or you are trying to advise them and manage them? Can you comment on it?
Certainly. So if you look at the past, what we've always been doing with regard to Java EE, now Jakarta EE, is looking at interesting specifications from our perspective. So there you may find the Servlet API and the JPA API, the Java Validation API. Those were really interesting specifications. And then look how the community would react to those, would be interested by them, and decide to actually provide support for it. So if you look at the Servlet API, so that's what we have with Spring MVC, and our integration with the Servlet API. If you look at JPA, it's mostly Hibernate, right? So we have a few things that are related to JPA, but not much. So we are watching that space, definitely. And this is the same thing for Jakarta EE. We're basically watching that space, see what the team and the community out there are going to produce, how the community will react to that if there is an interest. And based on the interest and demands from the community, we will add support for more specifications eventually.
Thank you very much.
Thank you.